Welcome back, guys, to our new lecture on theory of machines. Guys, we were doing the our first topic, that is the simple mechanisms and the various basic concepts that we studied in our previous lectures. You can go through those short videos that I have already uploaded. Guys, today we are going to do a new topic, new concept, that is the degree of freedom. So basically, what the degree of freedom is. डिग्री ऑफ फ्रीडम मीन्स ये जो है, ये वाली टर्म ये हमें बताती है कि number of independent coordinates that is required to describe the motion that shows the degree of freedom. Okay, so basically जो डिग्री ऑफ फ्रीडम है ये हमें बताती है कि अगर कोई लिंक है तो इसको कितनी डायरेक्शंस में ये मूव कर सकती हैं. ओके, तो अब जो आज का टॉपिक है हम इसमें देखेंगे कि हम कैसे डिटरमाइन करेंगे कि किसी लिंक की, किसी काइनेमेटिक चेन की क्या डिग्री ऑफ फ्रीडम है. ओके, फॉर दैट वी हैव एन इक्वेशन दैट वी कॉल्ड एज ग्रेबलर्स इक्वेशन. तो ग्रेबलर्स इक्वेशन क्या कहती है हमें? इट सेज डिग्री ऑफ फ्रीडम दैट इज द एफ इज इक्वल टू द 3 into L minus 1 minus 2J, where we already know L means the number of links and G means the number of binary joints. Okay guys, हमें यहाँ पे हैं चार केसेस. इफ वी सी चार केसेस में पहला केस है इफ द डिग्री ऑफ फ्रीडम इज जीरो. there are some members or some structures, some chains that in which the links do not possess any relative motion, and for those links we consider the degree of freedom equal to the zero. Okay, and they are called as the simply the frame and structures. So for the degree of freedom equal to zero, we will see there is the no relative motion. We will see there no relative motion, and they such structures are called as the frames. Okay, then there's another thing. We will later see that what are those structures and what are those figures, where we see that F is equal to 1, and they are considered as the kinematic chains. Kinematic chains. If F is greater than 1, then it is considered as the unconstrained chain. Unconstrained chain. Okay, and the last one is if F is less than 1, they are considered as superstructures. Okay, now let us see these one by one. Let's consider here we have a figure. Let's consider a figure with the three links, and if we see there are the three binary joints. This is the joint 1, binary joint 2, and joint 3. So here we have the links 3, that is 1, 2, and 3, and joints equal to 3. Okay, let us try to know about try to find out the degree of freedom. So what will be the F? F will become 3 into 3 minus 1 minus 2 into 3. So it becomes the 2, 3 2s are 6 minus 6, that is F is equal to 0. Means that degree of freedom is 0. Hence this is, there will be the no relative motion between the links, so it will be a frame or a structure. It is simply a structure. Structure with the no relative motion between the links. Okay, so how we were able to find out this was just because of the equation that we called as the Grabler's equation. Okay, we will take we will consider the another example. Let us see that. Here we have a figure, okay, with a different number of the links. Let us first of all see the how many links and how many joints are there. We see that. Let's count. Here you will see a ternary joint because there are the three links 1, 2, and 3. It means that the ternary joint is equal to the two binary joints. I will draw the two dots. Here is a binary joint, here is another binary joint, here is a ternary joint. So here is another binary joint. So how many joints are there net? 1, 2, 3, 4, 5, 6, or 7. It means that J is equal to 7. And what are the number of links? 1, 2, 3, 4, 5, or 6. So the links are equal to 6. Now let's try to find out the degree of freedom for this figure. Then F is equal to 3 into 6 minus 1 minus 2 into 7. So it will become 5 3 हो गया 15 minus 14. Okay, then here degree of freedom is equal to 1. So it will be a kinematic chain. It will be a kinematic chain. So ये वाला जो केस है ये kinematic chain वाला केस है. Okay, और for the और अगर degree of freedom 1 के बराबर होगी, and then I already told you that in the previous lecture कि जो J है वो होता है बराबर 3/2 L minus 2, और ये satisfy करता है इन दोनों को. Okay, for the kinematic. Let us take the another case. Yeah, if I consider the figure that I earlier mentioned, just a 4-bar figure with the 4 links, 1 link, 2, 3, and 4. If you see the number of binary joints is also the 4, so we have the joints equal 4 and we have the links also equal to the 4, then degree of freedom will be equal to 3 into 4 minus 1 minus 2j 2 into 4. So what it will be, it is 3, यहाँ पे 3 बनेगा 3 और ये बनेगा 9 minus 8. Here f is also equal to again 1. We earlier saw this was a kinematic chain, so here again we determined that this is again the kinematic chain because the degree of freedom is equal to the 1. Okay. If I consider the another example, let us consider number of links 1 2 3 4 और 5. तो ये बनेगा यहाँ पे links हो गया equal to 5 और जो joints है वो भी हो गया 5. 1 2 3 4 और 5 हो गया वो भी 5. It means that f is equal to 3 into 5 minus 1 minus 2 into 5. वो क्या हो गया 4 3 हो गया 12 minus 10. तो ये बनेगा यहाँ पे 2. It means that f is greater than 1. So ये कौन सा केस बन गया, ये हो गया अनकंस्ट्रेंट वाला केस. ठीक है, अनकंस्ट्रेंट चेन. ओके, so these are all the concepts that we studied. तो नाउ अब हम पढ़ेंगे सिंपल मैकेनिज्म्स. पहले हम देखेंगे एक मैकेनिज्म क्या होता है. गाइस सो फार हम पहुंचे अप टू चेन्स तक. तो हमने क्या देखा कि व्हेन द डिफरेंट लिंक्स आर कनेक्टेड टू ईच अदर एंड possessing some relative motion with respect to each other, they form a kinematic chain or they form simply a chain. But when we consider the first case, it is a kinematic. It means that for those degree of freedom is 1. and एक तो ये पॉइंट हो गया क्या कि हमने जो है काइनेमेटिक चेन कंसिडर करी. दूसरा पॉइंट ये है कि हम एक जो लिंक है अगर हम उसको हम फिक्स करें और हम क्या करते हैं कि जो रेस्ट ऑफ द लिंक्स हैं उनको रिलेटिव मोशन में रखें. एट दैट पॉइंट ऑफ टाइम वी कंसिडर दैट काइनेमेटिक चेन एज अ मैकेनिज्म. सो बेसिकली व्हाट द मैकेनिज्म एंड हाउ मैकेनिज्म इज फॉर्म्ड. सिंपली क्या होता है कि जो हमारे पास काइनेमेटिक चेन है हम उसमें जो है एक लिंक को हम फिक्स करते हैं. आफ्टर फिक्सिंग द वन लिंक एंड अलाउइंग द अदर लिंक्स टू रोटेट और टू मूव और टू शो सम रिलेटिव मोशन विद रिस्पेक्ट टू ईच अदर, एट दैट पॉइंट ऑफ टाइम वी कंसिडर दैट काइनेमेटिक चेन एज अ मैकेनिज्म. ठीक है, सो ये तो हो गया मैकेनिज्म की डेफिनेशन. ओके, नाउ there is another concept. What is now the simple mechanism? Simple mechanism, basically the mechanisms are of the two types. One is a simple mechanism and another is a compound mechanism. Okay, so पहले हम देखेंगे व्हाट इज द सिंपल मैकेनिज्म. सिंपल मैकेनिज्म किसको कहते हैं कि वो वाला मैकेनिज्म जिसमें कि सिर्फ होंगे 4 लिंक्स, 4 से ज़्यादा नहीं. सो द सिंपल मैकेनिज्म्स कंटेन ओनली द 4 लिंक्स. इफ देयर एग्जिस्ट द मोर देन द 4 लिंक्स देन इट बिकम्स द कंपाउंड. ओके, तो ये सिंपल डेफिनेशन है.